Alright, you guys, I'm going to teach you how to solve equations with the sine function involved in them. For example, the square root of 2 sine theta plus 1 equals 0. We want to find all values of theta between 0 and 360 that satisfy this equation. Now, this equation gets treated just like a normal equation where we solve for x, except this time we're solving for theta. And before we think about solving for theta, let's focus on just solving for sine theta. So we're attempting here to get sine theta alone. First things first, we should subtract 1 from both sides. We're left with the square root of 2 sine theta equals negative 1. Divide both sides by rad 2. And we are left with the sine theta equals negative 1 over radical 2. Now, negative 1 over radical 2 is irrational. We know that when we rationalize it by multiplying by rad 2 over rad 2, we're going to end up with negative radical 2 over 2. So we have here that the sine of theta equals negative rad 2 over 2. Okay, that's really special, except the question didn't say solve for sine theta. It wants us to solve for just regular old theta. So we have to continue. We have to think of angles where their sine would be negative radical 2 over 2. Radical 2 over 2 should be really familiar for you. That's the sine of 45, except this sine is negative. What that means is that the angles that answer this question and solve this equation live in the quadrants where sine is negative. Those two quadrants are quadrants 3 and quadrants 4. So this equation is going to have two answers, one angle that lives in quadrant 3 and one that lives in quadrant 4. We said that the reference angle that has this sine, rad 2 over 2, is 45. So it's the 45-degree angle in quadrant 3 and the 45-degree angle in quadrant 4. In quadrant 3 over here, 180 plus 45, that's 225. Over here, 360 minus 45 in quadrant 4 is 315. Two angles, two answers for this question, 225 and 315. That wasn't so bad. And also, there's a way to check these trig equations. In fact, there's two ways to check. The first way is algebraically, just like we always do. We could stow 225 and 315 as our x. So I'll do 225 stow x and 315 stow x. When I type in the left-hand side of the equation, the original, and the right-hand side of the equation, which of course is just 0, hopefully they will match. So here we go. I will do 225 first. So 225, stow that as x. And then type in the left-hand side of the original, the square root of 2 times the sine of x plus 1, and hit enter. And there it is, the 0. Let's try the same thing for 315. I'll stow that as x. I'll go up and get that equation that I already typed once. I don't want to type it again. And hit enter. And sure enough, the left side matches the right. 0 equals 0. So 225 and 315 indeed are correct solutions. One more way that you could check this is you could check it graphically. If you look at the graph of rad 2 sine theta plus 1 that I graphed on my calculator, I see that the zeros of this function are here and here, at least in that given interval. This one right here, halfway between 180 and 270, of course, is 225. In this angle right here, halfway between 270 and 360, of course, is 315. Another way to check these solutions. Pause the video and try the example below. Solving linear trig equations like we just did in that first example is very much like solving regular linear equations. Coincidentally, quadratic trig equations with a sine squared theta, sine, and a plane number, those equations are very much like regular quadratics that we're really good at solving. If I was asking you to solve 2x squared minus 3x plus 1 equals 0, you would factor 2x squared, the options are 2x and x. For 1, you can only use 1 and 1. In order to make negative 3x in the middle, they both need to be negative. X then equals 1/2, and x equals 1. We're good at solving these quadratics. It's the same method for solving quadratic trig equations. We can factor this, as long as we move the 10 over to the other side first. So we have 6 sine squared theta minus 7 sine theta minus 10 equals 0. Now we're all ready to factor. Let's go ahead and draw some factors. And here we go. The first question you should be asking yourself is 2 things that multiply to 6 sine squared theta. Now you could either use 6 theta and 1 theta, or 6 sine theta and 1 sine theta, or 2 sine theta and 3 sine theta. Let's go ahead and use 6 sine theta and 1 sine theta. 6 sine theta times sine theta, of course, is that 6 sine squared theta. The next thing you should be looking at is this 10. What times what could make 10? Well, 2 times 5 is 10. Let's try those guys. Let's go ahead and put 2 here and 5 there. If we do that and test out our middle terms, we have 2 sine theta and 30 sine theta. 2 sine theta and 30 sine theta could never give us 7 sine theta in the middle, so that's not the winning combination. Let's try this again, though, and just switch the places of 2 and 5. Let's put 2 over here and 5 over there. Let's double check our inner terms. We have 5 sine theta in the middle and 12 sine theta on the outsides. That's really good because that can make negative 7 sine theta. That will happen if the 12 sine theta is negative and the 5 sine theta is positive. So we have these things factored. Just like always, after we factor quadratics, we take each of those factors and set them equal to 0, and that's how we solve. So we have 6 sine theta plus 5 equals 0, and sine theta minus 2 equals 0. Like I said, let's solve these baby equations for sine theta before we worry about theta. First things first, in this first one, we'll subtract 5 from each side, and that gives us 6 sine theta equals negative 5. The last thing to do is divide by 6. Sine theta then equals negative 5/6. Our job is to find a theta where its sine is negative 5/6. We'll deal with that in a second. Let's solve the other equation for just sine theta. All that is a matter of adding 2 to the other side. Now 5/6 and 2, those should look a little bit weird to you as far as signs are concerned. I didn't memorize anything that has a sine of 5/6. I don't think anyone did unless you're a freak. There's another way to do that, the calculator. All we have to do to get rid of this sine next to the theta is take the sine inverse of both sides. Now be very careful. When you go to type sine inverse into your calculator, don't type that negative sign. That negative sign only tells us where these angles are going to live. Sine values that are negative live in quadrants 3 and 4. We just want to know the reference angle that has a sine of 5/6. So I repeat, when you type inverse sine in your calculator, never include any negative signs that are there. Only use the positive version. So here we go. Let's take the inverse sine of 5/6. What you're doing here is you're asking your calculator what angle has a sine of 5/6. The angle is 56.4427 degrees. The directions here say round to the nearest degree, so this angle to the nearest degree is just 56 degrees. The reference angle here that lives in quadrants 3 and quadrants 4 then is 56 degrees. Our final answers for this question are whatever 180 plus 56 and 180 minus or 360 minus 56 are. Those angles are the answers that live in quadrants 3 and 4. 180 plus 56 is 236. And 360 minus 36 is 304. You might be wondering what happened here. What happened with sine theta equals 2? Well, I don't know any angles where sine theta equals 2. If we take the inverse sine here, like we did, of 2, we can figure out what angle has a sine of 2. Once you hit enter, you have a non-real calculation. What's going on here is that sine values can never be bigger than 1 or less than negative 1. No angle has a sine value of 2. What that means is that we reject this solution. Sine theta equals 2 does not lead us to any solutions. 236 and 304 are our only answers for this question. Now, before you try one on your own, I want to teach you an alternative method to solving this quadratic trig equation. It's something called U substitution. If we first subtract 10, just like in the first example, we have 6 sine squared theta minus 7 sine theta minus 10 equals 0. If this scares you, if you're not trying to factor this quadratic trig equation, we can use a method called U substitution to make this less of a headache to look at. U substitution is a method used in upper level math to kind of simplify what you're doing without losing any of its meaning. All you have to do is pick something to be represented by U. In this scenario, the most logical thing to do is let U equals sine of theta. If we are going to represent every sine theta here with a U, this equation turns into 6U squared minus 7U minus 10 equals 0. This is a quadratic that you might be a little bit more comfortable factoring. Factors, of course, are the same, 6u plus 5 and u minus 2. Verify that 5u and negative 12u give you negative 7 in the middle. And we can solve these things for u. 6u plus 5 equals 0, so then u equals negative 5 over 6. If u minus 2 equals 0, then u equals 2. At this point, once you've solved for u, you should take whatever you said u was going to be and sub it back in place of u. So since we said u was sine theta, what we figured out here is that the sine of theta equals negative 5 over 6, and the sine of theta equals 2. Like we said, we must reject sine and cosine values that are greater than 2 or less than negative 2, and we need to work with this negative 5/6 sine value. That negative sign tells us that the angles that have this negative sign live in quadrants 3 and quadrants 4. So we're going to have two solutions for this question. Like we said, we need to figure out what angle has the sign of 5/6. 5/6 isn't one that we memorized, but if you use your calculator and take the inverse sine of 5/6, again, you find that 56 is the reference angle. If 56 is the reference angle here, then 180 plus 56, or again 236, and 360 minus 56, or 304, are again our two solutions. Pause the video and try the example below.